Today's objective, parallel lines cut by transversal. Let's go over some definitions. Parallel lines, they lie in the same plane that never intersect. Transversal, a line that intersects two or more lines. And in this case that we're going to be discussing is a transversal where it cuts parallel lines. Congruent angles, angles with the same measure. And the congruent symbol that you have seen before has an equal sign with a tilde on top of it. So that's for congruent angles. Corresponding angles, any pair of angles that have the same relative position at each intersection where a straight line crosses two others. I know that kind of seems a little confusing, but we will definitely see that as far as in the figure goes in just a little bit. In other words, here for the corresponding, they're going to be in the same location but on a different figure. Alternate interior angles, non-adjacent interior angles that lie on opposite sides of the transversal. Alternate exterior angles, non-adjacent angles that lie on opposite sides of the transversal. Same side interior angles, lie on the same side of the transversal between the other two lines. So again, in this case, those other two lines is going to be the parallel lines that we're talking about. Conjecture, a conclusion based on something observed. The things that we're going to be looking at and discussing in this particular unit, you're going to be able to make some conjectures based on what you see by proving information. All right, here's a diagram that will kind of help us with some of these definitions that we've been talking about. So you notice I have two lines, and these lines, as indicated, are my parallel lines, line R and line S. They are parallel. Okay, notice that line T here is my transversal, okay? And then if you notice that I do have all the angles labeled, so let's talk about the ones that are outside. So for exterior angles, those angles are going to be outside of the two parallel lines. So angles 1 and 2 would be considered exterior angles, and 7 and 8 would also be exterior because they are outside of the two parallel lines. When we're discussing interior, so for alternate interior or same side interior, we're going to be looking at the angles inside the parallel line. So notice that relationship for same side and alternate for exterior interior, we're talking about in relation to the parallel lines, outside or inside for interior to exterior. Okay. Big number 1, alternate exterior, alternate interior, vertical and corresponding angles are congruent. So what does that mean? That means that being congruent, that means they have the same angle measure. Vic number 2, same side interior and same side exterior angles are supplementary. So that means that they add up to 180 degrees. So we have a set of angles in Vic number 1 that are congruent, and in Vic number 2, those set of angles are supplementary. Vic number 3, all parallel lines are supplementary. All linear pairs are supplementary. Let's practice a little bit. Let's identify some of these angle relations. So I have the same type of a setup. We have parallel lines here. Okay, I know that R and line S are parallel. Here is my transversal. I labeled it line T. Okay, so let's talk about some alternate exterior angles. So remember what those are. Exterior, we're talking about outside of the parallel, and alternate is talking about opposite sides of the transversal. So let's talk about angle 1. So outside and alternate, so angle 1 and angle 8 would be alternate exterior angles. Let's go to angle 2. Which angle would be its pair for alternate exterior? So angle 2, go outside for exterior, and the opposite side of the transversal would be angle 7. So angle 2 and angle 7. Okay? Now alternate interior. Remember, interior, we're looking inside the parallel lines. All right? So let's look at angle 3. Inside, so at angle 3, alternate would be angle 6. All right? And then if I go to angle 4, alternate would be angle 5. Okay? Now remember, going back to corresponding angles. Corresponding angles, remember that they are going to be in the same location but on a different figure. So in other words, if I take line R and I slide that on top of line S, angle 1 would sit right on angle 5. So they are in the same location but different figure. So angle 1 is here on line R and angle 5 is here on line S. So they would be considered corresponding. And notice that these 4 angles, if I slid it down on top of 5, 6, 7, 8, they would be in the same location, and that's why they would correspond, because they're on a different figure. So angle 2 would correspond to angle 6. And 3 would correspond to angle 7. And 4 would correspond to angle 8. Okay? Now remember, vertical angles talk about when they sit opposite of each other, when I have 2 intersecting lines. Not necessarily the parallel, but when I just have 2. So we're talking about this particular set of a figure. So angle 1, 4 would be opposite of angle 1. And 2, 3 would be opposite of angle 2. So moving down to this figure here, angle 5 and angle 8 are opposite of each other. And 6 and 7 are opposite of each other. Okay? And what do we remember about alternate interior, exterior, corresponding, and vertical angles? All of their angle measure pairs are congruent. That means that they have the same angle measure. So when we start applying these angle relationships, we're going to definitely be needing to know that and remember that concept. So same side interior, okay? So we're talking about same side of the transversal. Interior, we're looking inside, okay? We're looking inside. So if I look at angle 3, what would be the same side of the transversal? Inside the parallel would be angle 5. So 3 and angle 5 would be considered same side interior. And then angle 4 and angle 6 would also be another pair of same side interior angles. Same thing would apply for same side exterior angles. So this time though, I'm looking on the outside for exterior in relation to the parallel. And then same side, I'm talking about the relation of the transversal. So if I look at angle 1, what would be same side of the transversal but outside of the parallel? That would be angle 7. So 1 and 7. And then if I look at angle 2 and angle 8. Okay? And let's look at linear pairs. Remember, linear pairs are supplementary and they must be adjacent and they must be forming that line. Okay? So if I look here, angle 1 and angle 2 are a linear pair. Angle 3 and angle 4. And let's not forget this direction, because notice that they sit side by side adjacent and they form that linear pair. So angle 2 and angle 4, and then angle 1 and angle 3. All right, let's move down here. Angle 5 and angle 6. And we're just repeating the same exact thing, just in a different figure. And then 6 and 8, and then 5 and 7. And again, what do we remember about the angle measures of same side interior, same side exterior, and linear pair? They all add up to 180 for each set of pairs. Okay. So let's do a little bit of application. Finding the measure of the missing angles. Okay. So same type of setup. I have my parallel lines. I do have my transversal. Okay. So for number 1, the measure of angle 2 is 75 degrees. Find the measure of angle 6. Well, here's angle 2. I know that this one is 75. And so what relationship is angle 2 and angle 6? Well, as you remember, they are corresponding angles. And so what do we know about corresponding angles and their angle measure? They are congruent. So that means that angle 6 is also 75 degrees. Okay? Alright. Let's go to a little bit more difficult question. This time we actually have 2 parts here. We have the angle of measure 3. I'm going to go ahead and get rid of this one. The measure 3 is represented as an algebraic expression, so we got to be careful there. So angle 3 is as 2x plus 1, and the measure of angle 4 is 4x minus 1. Okay, so now that I see the 2, you should be thinking back, okay, they're sitting adjacent, they are forming this line, so that means when they're adjacent, they're sharing that common vertex, that common ray. That means that they are forming a linear pair. So what do I know about them? Well, first off, I know that they both add up to 180 degrees because they are linear. So let's go ahead and start combining like terms. I know that positive 1 and negative 1, they add up to 0. So let's get 2x and 4x. We're going to go ahead and divide by 6. So x is, x is 30. Remember before, when we talked about solving for a variable, this is not the angle measure. Remember, the angle measure is represented as an algebraic expression. So we need to plug this in up here with x in order to get that angle measure. So 30 for x, so 2 times 30 plus 1 is 61 degrees, is the measure of angle 3. Okay? Same thing with number 4. I'm sorry, angle 4. Plug in 30, and we have 120 minus 1. That gives me 119 degrees. And remember how we can check this? Well, if I know that both of them are linear pair, 61 and 119 equal 180 degrees, which is what they should do. All right, that's how I can always check in my work to make sure that it is correct.